So welcome. I'm so excited to have you all here. My name is Magenta Strongheart. I am the head of design and partnerships at SupplyFrame's Design Lab. For those who are unfamiliar, SupplyFrame is our parent company. They own Design Lab, Tindy, and Hackaday. Tindy, if you're not familiar, is sort of an online marketplace for DIY hardware and electronics. A lot of our Hackaday members go on to produce limited runs of products and sell them through Tindy, so it's a great resource. Design Lab is our physical design and fabrication facility in Pasadena, California, just a few blocks from our SupplyFrame headquarters. Small scale electronics manufacturing equipment, CNC machines, small wood shop setup, injection mold machine, and 3D printers and some other digital fabrication tools. We do a lot of free programs, events, lectures, meetups, workshops, and things. And then we also host designers and engineers in residence a few times a year. Right now that's on hold, of course. We're sort of dedicating all our time to Hackaday Prize and the Dream Team Initiative, which we're really excited about. But when we are doing those things, my background is in industrial design, so I also help out with feedback and consultation and running the tools for our community members. So today I will mostly be the timekeeper and answering general prize questions, but if I have any input as far as industrial design and things like that, I will definitely chime in. Yeah, I think that's all for me. I'll pass it off to Alessandro to introduce himself, and then we'll get started with your projects.
Well, thank you. And I'm really glad to be here, actually. So this is my first of these sessions, so I'm really excited to have a chance to talk to Miguel and Robin for now, and let's see if the other participant joins. So my background, I guess, I'm a physicist, and I joined ARM 6 years ago as an electronic engineer. So I've been working on a lot of projects on different aspects of the electronics that we do. And right now, so in the last 2 years ago, I've moved to actually the developer relations team, and my role is really to kind of look after enablement. So how do we work with developers and help support developers building solutions based on ARM. So I'm really excited to have a chance to speak to all of you to understand what you're doing and see if there is any any of my knowledge that could be of use, and anything that I can contribute to your great ideas. I mean, I've seen them already, and they're just amazing, mind-blowing. So I'm really excited. Yeah, that's just a few words about me. I mean, obviously, ask me questions if you've got any specific questions later on. Be happy to answer.
Awesome, thank you, Alessandro. So yeah, without further ado, I think we should get right into the projects. As Alessandro just mentioned, we got a chance to look at everyone's Hackaday.io pages. So we do have somewhat of a nice context for everything, but definitely start with a brief sort of elevator pitch, 1 to 2 minutes summary of your project. And then if you have 3 questions prepared, we'll start with those, and then we can dive in with other feedback after that. I think we'll have a little extra time since there's less of us, so that'll be great, and we can get broader as we go, but want to start specific. So go ahead, Robin, if you want to get started with your exosuit, and then we'll go from there.
So hi, so this was a project what we have started like 1 year before. So what we want to achieve is like I want to tell you all a personal story. My grandfather, he was a really healthy man, and after having an accident, he was completely he was immobile. So he was completely dependent on different people. So even to do an simple utilitarian task too. So we came together to build something, and all the resources, I mean, like all the rehabilitation devices, everything what was available was inaccessible for common people, like people in India and this thing. So we came together to build this kind of what we want to achieve is I would like to give an analogy, like the polio vaccine was actually if it was like only for one company, we couldn't have achieved like making different polio vaccines, and polio wouldn't have been eradicated. So we want to solve this problem. So if it was an open source solution, so many developers, so many designers can work together and can actually make some assistive devices like exosuits, so that like it can change people. So when we took it to the rehabilitation centers, we found another aspect to this. Like we found that if um, before the age of 7, if we can actually rehabilitate, we can provide proper rehabilitation to kids with cerebral palsy, so it can actually change it. So when we were starting this project, we were actually working with an NGO. We were providing assistive devices for this NGO for CP kids. So we thought like this would be a very good thing. Like if we can actually improve this rehabilitation devices for to make it into a smaller version, so that like CP kids can actually do the rehabilitation, and if we can actually provide the feedback system, and if there is a proper dashboard, then the doctors can actually visualize it and can actually work on it. So what we want to build is like we want to make it really easy for the developers. We want to actually bring everyone together. We want to bring a platform, and like they can contribute themselves, and we can actually make this project into something else, so that like everyone can actually get benefit from it. So this is the whole project about. So um, yeah. So the in this project, what we have actually built is like we will have we actually planned it out as an SSJ device, but right now what we are planning is we are planning to put a stable structure around it, so that they won't fall, and they will be able to do the proper rehabilitation. We are actually working on that design, and we are also working on a specific microcontroller board with like motor controllers inside it, so that like they can actually print the PCBs and they can actually make themselves. So right now how it works is the Bluetooth actually sends signal to this exosuit, and it will actually make it work. So there are two motors connected in the two ends, and we are actually using a mechanical design in order to enact the walking pattern. So that's how it will work. So we are actually the design right now is a little really bulky. We want to actually bring it down. We want to add more motors if needed, and we are actually working on the new design of it. But right now we haven't tested it with uh, patients, but we have tested it with healthy people, so it will actually work. We have collaborated with some rehabilitation centers also to do the testings. So this is how it is right now.
Awesome, thank you. Did you have any initial questions ready to get started with, or would you like us to just dive in?
Actually, like we can go ahead, and I will have my questions after this. Yes.
Great project. I mean, it's really interesting. I guess my first question is, obviously this is um, a mechanical exoskeleton. Is there how are you going to program it to actually? What's your plan to program it to actually help? Is there like a pre-programmed kind of exercise that the person has to do, or is it learning what the person is capable of doing and then adapting on that?
So usually how the rehabilitation work is like a physiotherapist and the doctor has to literally take their legs and have to move it. So that's how it will work. So this one actually like will provide them that kind of structure, and will actually help them to like regain the walking capacity, like how a perfect gait will work. So that's how. So what we have added right now is one motor will be acting. One motor will actually provide one walking pattern for the one leg. So we want to actually change it into like 2 to 3 motors should be connected, so that there will be a perfect walking pattern according to the different people's size, shape, and like age and those things. But this is the initial stage. We want to actually change it. What we have came to know is like we need to add motors in the knees and the even in the ankle to provide the better walking pattern. But this will also work as an assistive device, not as a rehabilitation, not as a proper rehabilitation, but as a rehabilitation device.
Interesting. And I guess another question that maybe Magenta was going to ask, because it's more like design related than technology, but I was wondering. So you said you haven't tested it with people that have palsy, but
No.
have you perhaps like asked them? You know, is hexaskeleton something that like patients have ever thought of, or is it something that it's that sort of thing where you like kind of go there with like even a picture and say, is this something that would suit you? Like, would you? Yeah, have you had some
we have
feedback?
already done that. Yes. So as I told you, like we used to already like work with NGOs to provide assistive devices for the CP kids in the schools. So we actually showed them this thing, and we also used to speak with doctors about this. So proper rehabilitation before the age of 7 would be the most important thing, like before the bones are getting developed. So that's what we got the feedback. So I don't know, like I haven't seen a research studies like after the age, according to the age it will so I haven't find anything, but like before the age of 7 it will actually change their rehabilitation and they can actually work properly. So I think like for CP actually it shouldn't be used as an assistive device. It should be a rehabilitation device for kids so they can actually work.
Okay,
Yeah.
cool. And what challenges are you finding right now? Like, I guess, this is not to like put you on the spot, but it's more to understand, is there any way you think we could help or I can help?
Material what I was finding is like we need to bring it a little more lighter. That's one challenge what we are finding. The second one is like instead of using like we thought like we will actually make ourselves a microcontroller board in the name of like OpenX or something, and we can actually give it out to the hobbyists or hackers so that like they can actually code something, so that like if they want to build something else for the hands, or if they want to build something completely different for hemiplegia patients who are having strokes, so they can actually work on this device. So that's our for future plan. So I just want to know your insights about that, like how it will is that a very good plan, or should we move in another directions or something? What have you find any? So that's what we were actually planning.
Yeah, I mean, there's a project that comes to mind. I forgot, I'll get the name wrong for sure, but it's to do with helping diabetes patients, and it's an open source basically diabetes tester, and actually it's a pump as well. So it's kind of like the whole flow, and it's an open source project. There's a massive community behind it, and I think it's quite interesting because people with diabetes now can kind of work on their solution rather than have to buy something, or also because it's very expensive, right? So it's quite cool actually. So it's interesting to build a community around a solution or something that you think could be of help. I mean, in that case, I would kind of perhaps like think of it. I mean, I guess you mentioned about open sourcing the hardware platform, right? Is that
Yes.
kind
So
of?
what we thought was like we will have a microcontroller board with like motor drivers and those things completely inside the board. So so they can actually work on that. They can actually redesign it, and they can we will be providing the design like CAD designs and all those things. So they can actually change it if they want, and they can publish their own designs for hands, or like they have found some difficulties with the legs, so they can actually. So that we were actually planning to bring all the hobbyists and hackers together.
Yeah, I think it's really cool. I mean, there's a tool that I'm not sure if you know about. It's called Geppetto. It's an well, actually, it's not open source, so I shouldn't say that. But it's a tool that it's a company called Gumsticks that got acquired by a bigger company. But I mean, it has nothing to do with ARM, but it's an open source. So again, sorry, it's a free tool that you can use to actually do designs. And the interesting thing is that it does spit out a CAD design at the end, but it does also give you the ability to kind of create blocks or share blocks that you've created with others. So maybe that's something that might be interesting to look at. But I think overall, it's good. But I think it's a good idea to like open source this and have people feed into it. I guess it'd be interesting to think about who's going to feed into it. Is it going to be like the random hacker because he wants to help,
How
or is
we
it going to
plan
be?
was like, anyway, we are actually developing it. We are actually working with some rehabilitations and we are doing it. But by the same time, like we 5 members working together and like 2000 hackers coming together will actually change a lot. So we will get insights from these people. We will actually look into their projects, and we will actually build on our we will actually our research and development will be a lot more easier, so that like we can actually get insights from these people, so we can actually work. So that's what we plan. So our team will actually work with rehabilitation centers, and they will actually look into this project, and we will change our project time by time, and we will update the version 2, version 3, and those things, so that they can also work on that. So
yeah, my only feedback on that is to be very careful when because I guess you're thinking about kind of utilizing ideas that come from like open source development to then turn it into a product, right? So I think the way you do that is you got to be careful how you do that, right? Also for two reasons. One is ethical, because you're trying to like reutilize other people's ideas and perhaps like kind of commercialize something out of it. And the other one is also like people will be less likely to help you if you kind of keep it, well, if you say that you're going to kind of develop something, potentially there's less likely willingness to help unless it's an actual open source project that can be helpful. I guess if you're just using it to kind of drive ideas and then update your product,
but we're
then
actually
there could be less
providing
interest.
back to the community also, like, because like we are getting the insight, we will make a better version, we will provide it back to the community so that they can
Okay.
work. Yeah, so
Okay,
they can
awesome.
actually
Okay,
use
cool.
it for something else. So that's what I thought, like, not actually like use it to make some profit, but instead of that, like, we can actually develop, our team can actually look into this insight, and we can actually make some version 2 or version 3, so that like we can actually consolidate and we can give. So right now we thought like for education purposes, so that like so many people get interested to this exosuits kind of thing, and then like a hobbyist, so that they want to actually make something else, like they want to make a arm version of this, so that after that we can actually work with the hospital, so that like this arm version will actually help them in the rehabilitation of people who are suffering from some disabilities with the arm or something. So we were actually planning to make a platform around this.
I wanted to answer the question material quickly. You mentioned wanting a lighter material. Is there a reason you guys started with iron? Because that is one of the heavier metals. Have you considered aluminum potentially?
Because like welding was much more easier for iron, so that's why we started it with iron. So we are actually planning it out like some better material, so that like it will be a little more lighter, so that it will be smoother in movement and those things.
Yeah, I think aluminum might work nicely. It's also really easy to machine, and there's a lot of both small scale and large scale sort of ways to manufacture aluminum parts, especially out of sheet stock. It is can be pricier, but I think it'll be a great improvement weight wise. And then also looking into, I don't know, all the requirements as far as rigidity and flexibility are concerned for your design, but looking into some denser plastics potentially might be worth checking out as well. You'd have to do some research, of course, on which would be best, but there are some pretty strong plastics used in in equipment that's at this level of application, as far as needing it to still withstand stressors and things. And then I wanted to make sure, we have enough time to get to Miguel's project too, before we get too far down the rabbit hole of questions. But there were a few things I wanted to note that I think will be applicable to Miguel potentially as well, just because they're sort of general page organization recommendations for the project logs and things. So at the end, I'll share my screen and go through where to find some of the criteria in the official rules, because that's really important to make sure you're on top of before the entry period closes August 31st. And then also, if you guys make it to the final round, there's additional criteria for the final round of judging in October. But part of that is the number of logs, so make sure you're looking at that, and we'll look at the specific number when we pull that up. And then some of the things you mentioned when you were talking, but I didn't necessarily see elaborated much in your page, but I think would benefit from more description are sort of the benchmarks, which is also one of the judging criteria. So benchmark is considered sort of like competitive analysis, or what else is out there and how yours compares. So the way you talked about, you know, solutions that are already out there are either too expensive, or they're not, you know, they're not as elegant maybe as this solution. They're not as refined or technologically advanced. So actually comparing things that are on the market or commercially available and why yours is better, or maybe even other open source designs and why yours is better is part of, you know, something that can make your project stand out. And then also just general organization of the page. I always recommend to everyone to do a version, whether it's a separate log or how you organize your project details, do some version where it is based on the judging criteria, because that just makes it extra easy for the judges to zoom in on how you're answering those questions. So when it comes to concept, design, production, benchmark, and communication, if you just look through those questions that I also included in the email for this mentor session and make it extra obvious, you know, this is how I'm addressing these things, then I think it's a way to definitely sort of level up your page. So I think, you know, I'm sure we'll have some time at the end to get back to more questions, but let's give Miguel a chance to talk about his project, and then we'll do general, we can come back to more questions at the end if that's all right, Robin. All right, thank you, and incredible projects, for real. Excited to see the development of it.
So this project is just like, I always have been amazed about this type of robot, and why not to build one. So this year I have been I'm undergraduate in physics. So this year I have been working on some subject about control theory and all its maths and everything involved in this field. So I get very motivated, and I started to design a quadruped robot, and you know, to read and understand all the math below, because what I saw in internet is that the problem is the math are not precise enough. So as I'm a physics in my fourth year, and I'm not really good about at this, but you know, I'm starting to learn the maths and to understand it, and I can take a paper, read it, and understand. So I start to read all the paper related with with this type of robot and understand the problem, and that's all. I start writing the code about 1 year ago, more or less, and now it's coming along very nicely. You can see in the videos it works and it do some movements. It is not very precise because I'm not looking for a very robust math model, because this is not any professional robot or any researchment, just a hobby. So this is the robot. You can see here. It's not very big, but it's nicely done. And I don't know. I always have been seeing this page. Oh, I really like Hackaday, so why not to documentate everything? And I started writing, and then noticed the contest, and go for it. I don't know if I can say something to it.
Yeah, thank you for the introduction to the project. Did you have specific questions you wanted to start out with?
Yeah. As my problem is that I'm not very good at you know, at programming, and because in physics Alessandro knows, there is a lot of math and you don't really apply them. So my questions are, is it Python enough for this task, or I may move to ROS?
Good question. I personally think you should look at ROS because I think it would help. There are a lot of things that you might be developing. I'm not an expert in ROS, but I work with developers that are, and I hear that there are a lot of things that you might implement. You might end up implementing by yourself, where with ROS you would kind of leverage the platform, right? Like there is the concept of sending messages in different ways, and it's clever enough so that you don't have to like re-implement everything from scratch. So I would say I would recommend to have a look at it because I think it could help. Especially, I mean, it seems like you've got a lot of different motors on that, and there is a lot of probably communication that needs to happen. I don't know how much communication you've got between the different legs, how much feedback you have.
Yeah, this basically there is two communications. One is the IMU data, which is read, and then with this data, it make all the calculation needed, and you write the PWD signals, which are basically the signal in order to move the servos, the servo motors. So there is no much messages to send, but for example, now this communication I'm doing with a Raspberry Pi for the Python code and all the math model, and then all the signal treatment is made on an Arduino. And this communication is made via serial communication, which is not the fastest, but it's okay for now. It's okay for now, but I want to implement some other sensors that maybe in the future.
Yeah, I think that's when it becomes important to use ROS, right? Because every time you implement more sensors, you're gonna have a challenge of how do I communicate to these sensors? How do I get data? How do I manage to like share data around the system? And I think that's where ROS could be of help. Plus, I think it comes with like security features as well, and like some other interesting features that might that would take time to implement. So, and also, I mean, it's another interesting thing to learn, right? So I think perhaps it's worth the time. I mean, it's taking off. There's a lot of people getting involved. You might have actually the ability to also get help from the community. I think this is an exciting project, so I'm sure that if you bring it up, if there might be people willing to jump in and like provide a hand, right? So I think it's definitely I think it would definitely be worth looking at it and seeing whether it's too much overhead for what you're doing right now. I think depends on when you're trying to add the additional sensors and what your timeline is. But yeah, definitely look at it, I think.
Yeah, we have already a community. It is called Spot Micro Community. It's
nice.
another version of the robot, which is very similar to the Spot from Boston Dynamics. And yeah, this community is growing every day. Now we are like 500 people. It's really nice. Yeah.
Is it Spanish or?
No, it's all around the world.
Oh, okay, cool.
Yeah.
Cool.
And other question I have, it's about more like about the Raspberry Pi. If it is powerful for calculations, for having a model and solving it, integrating all the time in real time, and the goal, it could be the online calculations.
What are you finding so far? I mean, is it giving you problems? Is it do you feel like you have got limitations, or I mean, it's all a balance between it's a trade-off between power consumption, power, like computational power, and cost as well, right? So area as well. I mean, depending on what you go for, but I think it's a trade-off that you're playing there, right? It's what you need. Is it serving what you need? And then if it's not, then you can think of upgrading.
Yeah, because for now it's okay. It's okay. My code, which is in Python, and I'm not really an expert. It can be speed up a lot of. It take the Raspberry to its 50-60% of the microprocessor capacity. But okay, well, I don't have any tool or any model, any difficult calculations. Just is a model, a direct model in which I don't have tools like Casadi, to make to integrate a model. I don't have any filtering, any Kalman. I want to implement a Kalman filter, and maybe solving this would be much harder for the Raspberry Pi, and maybe online calculations could be a solution, but I don't know how can I implement it easily, not without making a research.
When you say online, you mean on the cloud, like some other.
Yes, something like that. For example, I can have a computer, and a big computer, and communicate with the Raspberry Pi, where in the computer I have all the model, or the big model, or more or less, and then the results are commanded online to the Raspberry Pi.
I think you could go both ways. So I'm actually really interested in the aspects of how do you make stuff run efficiently on smaller cores, right? So I'm actually interested in, my personal interest is how do you actually get machine learning models, for example, running on really tiny cores.
Yeah.
And, Raspberry Pi is kind of like a low end, let's say, right? A single board computer. So it's an interesting problem. Now, obviously, the more cores you have, the more performance you have, the easier it is, right? So it's like, I think, perhaps like it depends what you're trying to do, right? If you're trying to build something that's cheap, that's power efficient, maybe you can run for much longer because you're not, burning a lot of power sending data around. I think every time you turn on a radio of any kind, you're burning you're burning power, right? If you can keep all the processing on the device, you're actually saving a lot of power. So if you want to run this off battery, it might make sense to do the processing on the device. Now, it could be that the more if you scale this, it might make sense to have something like a Jetson Nano, for example, on the device. I've seen a lot of robots with Jetson Nanos, or there is the new Jetson Nano, I forgot what it's called,
Xavier?
NX, I think. Sorry?
Xavier or something like that.
No, the Xavier is the big one. There's another Nano that just came out, more powerful. There's a couple of like Jetson. I could look it up while we talk afterwards. But there's a couple of Jetson boards that are kind of good. They've got like I think quad core ARM A76 or something, but then they also have a GPU, right? So you've got the dual kind of processing, and you could, depending on what you're doing, you could do the processing on one or the other device. And it's all integrated, so it's easy to use. Also, they're very well supported with ROS. So if you do go ROS, like they're very supported. The other thing, I guess, worth mentioning is you might think of having like something that's running all the time and doing like some basic stuff, and then you could have another device that's actually doing the more complex stuff. I'll give you an example. You're trying to avoid obstacles, right? So you could say, well, every time I think I see something, I turn on another computer, let's say, that can tell me whether that's something or not, right? Like you can kind of like think of staging the approach, right? So you could do like a really simple calculation on the device right away. So quick. So it's like, no, I don't see anything. I don't see anything. I don't see anything. So you keep on going until, you have a doubt. When you have a doubt, then you turn on something more powerful. So those are like ways to reduce the power consumption, right? So you kind of keep something that's running all the time, that's always that's very low power, and then you kind of turn to something that's more powerful, but also more power consuming. If
Yep.
that makes sense.
And you mean this in the same device?
So you could have, in the same device, you could have multiple, multiple cores, or multiple, you could have maybe a Raspberry Pi and a Jetson Nano, for example. I mean, that's probably crazy, but like, you could think of things like that, or you could think of still doing most of the compute on the Raspberry Pi and then sending something off to the computer, like you were saying, in the case in which you need to. So you're doing computer vision, like, for example, you detect a person. So like detecting a person is quite low. It doesn't require that much compute. So you could say, yes, this is a person. But then if you want to detect Miguel, and make sure that Miguel is not Alessandro, that's actually more complex, right? So you might want to do that computation somewhere else, right? But you're still able to detect whether it's a person right away on the device itself by not consuming much power on the Raspberry Pi. And then you can, pass some more like complicated information to the other device, to like something outside. So the real time, basically what I'm saying is the real time stuff you could do right directly on the Raspberry Pi, and have someone else, some other computer help you to do more complex stuff that you might require. That's not so important in a real time sense.
Interesting. Yeah, I like it.
It's called Xavier NX, I think. Yeah, Xavier NX. Yes. So it is Xavier, but it's NX. So it's a tinier Nvidia. And again, I don't work for Nvidia, so I'm not promoting it, but it's just I think it's something that came out recently, and I've seen people use it.
Yeah, they seem to be very powerful for this type of things. Seems.
Miguel,
Yeah, and again, I think
have,
it's.
I was just going to say
No,
time for one more question maybe, and then I have a few notes, and then we'll get back to general info. So this is your like 1 minute warning.
I don't know. What do you think? Is this good to open everything, or maybe it could be dangerous, as you told? It could be dangerous in bad hands, or is it no problem with this scale of thing?
It depends, I guess, what you're trying, like where you're putting it, right? Where you're having it, where you're using it. I mean, it doesn't seem like it's a heavy object, so I wouldn't be too scared about it. But then again, maybe I wouldn't put it in the hands of kids, right? So like, I think there's a balance there as well. Can I ask you one question, actually? I mean, there's a big community of people developing this stuff. What is that makes this solution different? What is it that makes it special?
Because I almost do all the research, all the development. So all this math. Okay, well, the thing is, all these maths are not really trivial for people which are not familiar. So when I upload the videos, I started uploading videos of the development. All the people were asking about the maths, about how the model works, and I think the Hackaday page is the perfect site for these type of things. So I go for it, and now now I see that there were a contest, but this wasn't really the theme of the documentation. It was just in order to help the people we understand the maths.
All right. So I just wanted to say a few things. One thing I wanted to say is that I totally understand, as you said, it was sort of started as a passion project and interest for you to, push yourself and develop this. And that's what the wildcard category is for. So totally works for that. But I do want to just plant the seed of, there's still a little over a month left to continue developing it before the entries close. And I think there are some ways that you might be able to adapt it or even develop some modular add-ons or things that would be applicable to many of the challenges that are with the different nonprofits, the 4 different nonprofit challenges. And I would challenge you to consider this because not only is there a greater monetary incentive, you probably saw the prizes, you know, do go up as far as the wildcard entries are only eligible for the one $5,000 award, but the nonprofit entries are eligible for the honorable mention awards. So there's 4 honorable mentions at $3,000, and then the best of the nonprofit category at $10,000, and then again the grand prize, of course, of $50,000 is only for nonprofit challenge entries. So something to consider. I think also, you know, Hackaday is a great community to even post if you're not feeling necessarily inspired by one of the challenges, saying, you know, hey, I think there might be a way to adapt this. If anybody has ideas of how I could adapt this for, you know, to help as an assistive device or to help with the Conservation X Labs challenge of, you know, the ghost gear and different things like that, you know, feel free to collaborate with me or something like that, you know, because you haven't gotten very far along. So I just want to plant that seed. Obviously, no pressure. You're welcome to do, you know, what you like as far as that goes. And I think it's a great wildcard entry, but want to throw it out there. And then something else I wanted to mention to Robin about your project that I forgot to was even in the 2 applications you described, verbally, the rehabilitation versus the assistive device, I think you could dig into that a little more in your documentation and just elaborate. I think it's always useful to sort of, you know, paint the picture of how this is going to function in different applications. And I think that would be really, you know, interesting to the judges and interesting to UCPLA as well. Because I think it is important that, you know, that it's dynamic as those 2 sort of applications. And I also wanted to recommend to you that we will have a mentor session with a team member of UCPLA on August 12th. I don't think it's on the form yet, but it should be updated this week or next week. So keep an eye out for that, because I think it'd be great for you to talk to them as well if it's, you know, if there's still an opening available for that. And then I will, like I said, go through the rules really quick, but I'll save that for the last 5 minutes. I want to leave this 5 minutes here from 9:50 to 9:55 for any other comments or questions or any peer feedback you guys wanted to give each other potentially. And then I'll do the spiel at the end as far as where to find the rules and that sort of thing.
Yes, so as Mikkel was telling, like even I also feel like to add ROS to this, like because recently like I was also working with ROS. So what I found was like it will actually go to a next level, like if you are actually using that. And it is a marvelous project. Anyway, like if I get time, I will actually try to build one.
I almost wonder if you guys could join forces and create a combination of the 2 things.
Yes, yes.
Right, that could be incredible.
I have a question about the challenge. I submit the project to Wildcard because I think this project is too complex for the challenge that has been that there are on the non-profit. But is it mine really this application in the challenge has to be made in a short time, or maybe there are is it to in order to take ideas or in order to motivate another group?
Yeah, let me make sure I understand your question correctly. So you're asking if the entries to the nonprofit challenges, if the goal is to offer a solution that can be recreated really quickly, or if it could be something that takes a longer amount of time, essentially, or something more complex.
Yeah, the thing is that that challenges are gonna be implemented on the non-profit community groups, or are just like to take some ideas for the future?
Yeah, so we don't exactly specify, except for the grand prize winner. We do have, we do say that you get the money and a Supply Frame Design Lab residency, which we keep very open-ended because it really depends on what the project is and where in the world the winner is located, and how far they want to take it, whether it's they want to take it to design for manufacture, or if they are interested in just documenting it or progressing it a little further as far as the development of the solution. So there's actually no part of the criteria that's about how quickly you can reproduce it. It's more how effective is your documentation so that it is reproducible, if that makes sense. So as long as it's documented thoroughly enough and in a way that someone could potentially recreate it or go to design for manufacture, potentially the nonprofit organizations, we want them to have the opportunity, if they wanted to apply for a grant to then recreate a bunch of these. They have the design package to do so, not necessarily not for profit, obviously, because they're not for profit, but to be able to implement in the field. So there's no pressure to the entrants that they should be able to reproduce 100 of these 2 months after winning or anything like that. So hopefully that clears that up. So it's really about the nonprofits wanted a fresh set of eyes on their challenges. A lot of these challenges are things they've been thinking about for a long time, and if there was a solution that was easy to answer, they would have done it by now, or it's really inaccessible and at an insane price point, or hard to source the components in remote areas, or different things like that, depending on the organization. It's been awesome to see the creativity and innovation of the Hackaday community, because most of the members of the community are not so buried in the organization that there's so many other things they have to focus on. The organization can't necessarily access this kind of engineering talent, so we're excited to bring that to them. All right, I'm just going to quickly go through the rules section so that you guys can follow along with that, and then feel free to ask questions as we go, or let me know if I'm going too fast or too slow or anything like that. So here we are on the contest page. If you ever have trouble finding this, if you go to contests up here in the toolbar, it just pops up on that menu. So Supply Frame Design Lab Hackaday Prize. And you can find the rules pretty immediately here in the details. So official rules are right here. This is also the same copy that is on the main website you may have been to, that's prize@supplyframe.com. And there's just a few things I want to point out here. I know it's an overwhelming, legal document, but it is important to take a look at the entry round requirements, which is what I mentioned. These things are required to be eligible for the first round of judging at the end of August, beginning of September. So this was the number I was looking for, the 4 project logs. So make sure you have a minimum of 4 project logs. And there's a few other things in there. Publish at least 1 image. I think you both have that covered. And open source licenses, etc. And then for the final round, this is important as well. If you make it past that first round, but I think you all are have most of these things actually, as far as a working prototype, which is awesome that you guys can already check that off the list. And videos, you both have great documentation through video of your prototypes, so that's awesome. And so just want to call attention to these things. Again, show at least 10 project log updates. And then again, the judging criteria can be found further down in section 6 in competition criteria. We have the entry round, which is a little more general version of that same criteria I copy and pasted into the email body, which is concept, design, production, benchmarking, communication. If you guys have any questions as well, you're welcome to email that email you received the invite for this mentor session, the prize at prize at hackaday.com. There's usually, it's me or one of my colleagues, and we're happy to answer questions as well. We want everyone to feel like they have the tools to succeed. And then I also want to mention a few things about this page. And also in general, we have a monthly newsletter going out to all the prize entrants. So if you feel like you're not getting that, please email that, the prize email again. Check your spam as well. Unfortunately, sometimes it goes to spam because it is, sent out through MailChimp, so we can't control that. But in there, we have the updated schedule of the mentor sessions. We have links to videos and articles that might be useful. We do a project highlight each month as some standout entries, important date reminders and things like that. So if you're not getting that, please let us know. Check out Hackaday's YouTube channel because we often upload the videos. So there was Q&A sort of interviews with each nonprofit about their challenges that has a lot of insight in those. So there's 4 different videos there you can check out on Hackaday's YouTube. And then lastly, I want to mention that and of course the design briefs are all here as an image, but also they are in the logs if you want to get more in depth. Each design brief, each nonprofit has their challenge elaborated on their challenge page. So you can see that on each of these pages as well. And the other thing I wanted to mention is if you guys were participating in the community vote bootstrap sort of contest halfway through, we'll be announcing the winners of that on the 17th. So in just 2 days, I believe. And that's when we give out the $500 sort of bootstrap money to 20 projects. So 20 projects are selected from the top 100 most liked projects. And I think that's all for my updates. So if you guys have any other questions, feel free to ask them now, or any last questions for Alessandro.
Can I share my contact for people to reach out in case they've got questions? Yeah, is that right?
Yeah, and I can also send that to everyone via email. I can connect you all.
Yeah, I'm sending. So this is my Twitter. And obviously, you can find me on LinkedIn. You can find me on LinkedIn. Like, Twitter is open. You can find me on LinkedIn if you want. Yeah, if I don't know the answer, I could connect you with someone that does.
Okay, awesome. Well, thank you so much for being here. Huge thank you to our mentor, Alessandro, for your insight, and also for just everyone's participation and engagement. We're really grateful that we can offer these sessions, and it's always wonderful to hear everyone's enthusiasm around their projects they're developing. And tell your friends to enter or to contribute to your project. There's only a little over a month left to wrap up those entries, and we're really excited to see where they go as far as the selection process as that continues. So hope you guys have a good rest of your week, and feel free to reach out to that email anytime if any other questions pop up.
Yes.
Thank you.
Thank you very much. Thank you, Magenta, for having me, and thank you, Miguel and Robin. Thank you for presenting your project. Good luck.
Thank you so much for your
Thank
time.
you.
Bye-bye.